Good morning.
Chemistry 121 students. My name is Tom Gill, and I'm going to be talking about experiment 12, and then we're going to go in the lab and actually run the experiment. Okay. So this experiment is a very simple way to find the value of the ideal gas law constant, and that's what we're going to be focusing on doing today. So what we're going to do is we're going to react some magnesium, metallic solid, with hydrochloric acid, and that's going to produce magnesium chloride and hydrogen gas. We're going to collect the hydrogen gas in a device called the Udiometer. Let me show you the apparatus, okay? I'm not really good at art, so I actually just kind of downloaded this off the internet. But basically, to do the experiment, we're going to take a little piece of magnesium and weigh it, and then we're going to tie it onto a copper thread or copper wire, which is connected to a rubber stopper, right? The Udiometer is basically a long test tube that's got marks for the milliliters marked off. And what we're going to do is we're going to fill the bottom part of the Udiometer with some hydrochloric acid, around 8.5 mils of concentrated. Then we're going to fill it all the way with water. And then we're going to insert the stopper, which has the magnesium tied to that copper wire, and then we're going to invert it into a water bath. Okay, and what will happen is when we invert this, the hydrochloric acid, which is more dense than regular water, is going to mix and filter its way down towards the magnesium. So it'll take maybe a minute or two before we start to see a reaction, and then as the hydrochloric acid combines with the magnesium, we'll start to see bubbles form of hydrogen gas. Okay. And this will continue. Each trial, I figure, is going to take about 5 minutes to do. And then once the reaction is completed, what we're going to do is we're going to take our Udiometer, which is inverted. Okay, so I've made a little cutout of a Udiometer. And we're going to move the water levels so that they're the same. And the reason we do that is it's not practical for us to insert a barometer into here. Okay. And when we have the water levels at the same, the barometric pressure, which we can measure using a barometer, is going to be equal to the combined pressure due to the hydrogen gas, which we generated, plus the pressure due to water vapor. Now, in your laboratory, they actually give you a table of water vapor pressures as a function of temperature. And at the end of each experiment, we'll actually measure the temperature of this water bath. You can use that to look up the vapor pressure of water. Okay, so that's the experiment in a nutshell. Let me go through a few things with respect to the calculations that we're going to do. Okay, so we're going to measure the barometric pressure with our barometer. Okay, and that barometric pressure is going to be equal to the vapor pressure of water at that particular temperature plus the partial pressure of hydrogen gas. Now we're going to calculate this originally in millimeters of mercury, and if you look at the data table in the lab write-up, you're actually asked to give the partial pressure of hydrogen in both millimeters of mercury and ATMs. So for each line, each trial, put both the millimeter pressure and the ATM pressure down. Okay. All right. So that's how we calculate the pressure. Okay. The volume, we're just going to measure it straight from the Udiometer. And so Udiometer reading is similar to reading in burette. We're just going to compare the final reading minus the initial reading to get the volume. Okay. And again, that's going to be in mils. And of course, you'll need to convert that to liters to do the gas law calculation. Okay, to get the number of moles, well, we take magnesium and we react it with hydrochloric acid to make hydrogen gas plus magnesium chloride, which remains in solution. Now, from the mass of the magnesium, we can find out how many moles of magnesium form. And from the stoichiometry of this equation, we can find out how many moles of H2 form. Okay, so we've got the pressure, the volume, the number of moles now, and the temperature. We're just going to measure that from the water bath after each trial. And again, to do this calculation, you're going to have to convert it to Kelvin. Okay, so just a couple more things I wanted to point out with respect to the lab report. If you notice, we're going to make 3 measurements, right? And we're going to take those averages, right? So what we're going to do a couple of things. We're going to do a calculation called the deviation from the average and average deviation. This was fully explained in experiment 2. So if you forget how to do that, just go ahead and watch the experiment 2 video, okay? And we're also going to have to calculate a percent error, okay? So we're going to compare the result we get experimentally from the theoretical value for R, which is actually given in the lab report, okay? And I noticed that there is a grade on precision and accuracy. So I hope for your sake that I do this precisely and accurately so that your instructor doesn't knock off points for experimental technique. Okay, and so that's it for this lab. And we're going to go in the lab now and actually do the experiment.
Okay, so the first thing I'm going to do is weigh out my magnesium sample. And we can see the mass down there. You're going to need to record that in your notebook. And then I'm going to put the magnesium sample on the bottom of this little copper wire. And we're using copper because it won't react with hydrochloric acid. Right? And now to prepare the Udiometer, I'm going to first add about 8.5 mils of concentrated hydrochloric acid. And then I'm going to fill this all the way up with distilled water. So most of the concentrated hydrochloric acid is on the bottom, and above that we're going to have water. And now let's put this stopper in here. Okay, so what's happening is at the bottom of the Udiometer, which is now inverted, so it's the top here, we have the concentrated hydrochloric acid, and it's mixing with the water. So these little swirls that you see are due to the refractive indexes of these solutions being different. So even though they're both colorless, we can see that they're actually mixing. Okay, so eventually the hydrochloric acid is going to make its way down to the magnesium, and then it'll start to bubble. Okay, so give it about 30 seconds, another minute or so, we should start to see some bubbles form. And you might not have noticed, but the Udiometer was filled at the start, so our initial volume is going to be 0 mils, okay, which you're going to use in your notebook. And you can see the magnesium coil there.
You can see the bubble. You can see the bubbles on it now.
All right.
So.
Okay, so it's starting to react, and you can see the bubbles coming up. You can see the reactions a lot faster now. We're getting a lot more bubbling. So the bubbling's pretty robust now. We'll probably be done with this trial in a few seconds. A little piece of magnesium broke off though. Okay, so it looks like the reaction's complete at this point. So what I'm going to do is I'm going to adjust the water level so that the water level in my Udiometer tube is at the same level as the level in this reservoir. And then we can read the volume of the gas that's contained in there. The reason I'm doing this is to make sure that the pressure in the room, the atmospheric pressure, is the same as the pressure in the Udiometer tube. We can get the measurement. And then we still have to measure a couple other things. We have to measure the temperature and the pressure in the room, which we'll look at in just a moment.
Okay, that's good.
You
For
got
the
a good
volume.
reading?
Yep, got
Okay.
it going for that.
And let's go over here. And this is the pressure. Or wait, I'm sorry, that was the temperature. Okay, so this gives us the barometric pressure in inches, right? So you're going to have to convert that inches to millimeters and then later on to atmospheres. And then our temperature is recorded in degrees Celsius. And now we should have all the data we need to do the first R calculation. Okay, so here's trial 2. I've put the magnesium on the balance so we can look at the mass. And let's put that onto our copper wire. 8.5 mils of concentrated hydrochloric acid. Now we're going to fill up with distilled water. So notice that our initial volume is 0. You can see the Udiometer is completely full. And again, we can see the mixing of the different liquids, the concentrated hydrochloric acid mixing with water. And now it's time to wait for a few minutes for the reaction.
Go to the kitchen and get a snack.
Exactly.
Pretty vigorous now. Uh-oh. It broke free. Did you see that?
Yeah, but it's still reacting.
I don't see any of it, so.
Okay, so now we're going to equilibrate the pressure and measure the volume. Let's adjust this so the water level's about the same. Okay, so you can get the reading. That looks pretty clear, right?
Yeah.
So I'm just putting it slightly off the edge so we can see where the barometric is. Okay, and so now we just need to look at the pressure and the temperature of the water bath. Okay, the pressure there, 27.73 inches. Inches mercury, and there's our temperature. And that's it for trial number 2. Okay, so first thing we're going to do is get the mass of the magnesium. And then I'm going to put this onto my copper wire.
Sorry, for some reason it turned off and you pointed out that it was 0, so I just wanted to show them it was 0.
Sure. Okay, so the reaction's completed. The next thing for us to do is to equilibrate the pressure and take our volume measurement. So I'm moving it slightly below the water level so you can see the
Beautiful.
meniscus. Okay, so you got the measurement.
Uh-huh.
All right, and now let's check on the pressure and the temperature in the water bath. So there's our room pressure or atmospheric pressure, 27.73 inches of mercury, and there's our temperature measurement. And that's a wrap.